Electrical resistance. In formula for electrical resistance, R is equal to ρ multiplied by L divided by A. In this formula, R represents the electrical resistance in ohms. The Greek letter ρ indicates resistivity in ohm meter. Electrical resistivity, also called specific electrical resistance, is a fundamental property of a material that measures how strongly it resists electric current. Resistivity depends on the material of the conductor and the temperature. For example, the resistivity of iron is different from that of copper. A represents the cross-sectional area per square meter. Suppose a wire of a certain thickness has a number of electrons passing through it. If the thickness of the wire decreases, the transmission electrons also decrease, and in fact the electrical resistance increases. Also, the electrical resistance decreases as the cross-section increases and electrons pass more easily. The letter L indicates length in meters, which is directly related to electrical resistance. Now it's question time. There's a wire with the length of 1.1 meters, and its cross-section is 3.1 multiplied by 10 to 6 meters, which is in insulation material. The resistivity of this wire is 6.8 multiplied by 10 to 5 ohm meters in 320 degrees Celsius. Calculate the electrical resistance of the wire in this temperature. Now the answer. According to the formula of electrical resistance, we'll have